Climbing Club overall was pretty straightforward, except for the part at the end where I made you make distinct peaks uh, work properly, and that was a little tricky. But I'm gonna go over the first two parts. Part A, you're just supposed to add a new mountain, and um, what you're adding is a new, what is it, climb time item. You know what? Give me 1 second. I want to get the name right here. Oh, come on. All right, here we go. A new climb info item. That's what it is. And every climb info um, stores a peak name and a climb time, of course. Um, so that's what these represent. So anyway, I'm saying the basic add climb, you just add a new climb to the list, and so you just call the array list add method. Easy. The other one is a little bit trickier. Here, they're sorted by name and not at all by climb time. And so as this example shows, you know, these two could have had the way they are, they could have been switched. Either way is valid. Now, funny thing is, when I was doing this, I was thinking very much like insertion sort, where with insertion sort, you know, you have a fully formed array that you're trying to sort, and so you know, you take the second element, insert it, and then the third element, insert it, and so forth. And so with an insertion sort, you're always basically starting from the end of the list, just automatically, because that's where the next element is. It's right after the sorted part of the array or array list. Here, on the other hand, you know, you have a fully formed list. I mean, you presume the list is sorted because you're maintaining it that way, which means when you go to search the list, you don't have to start from the end. You could start from the beginning. And so here, let me just show you. Come on. So if you look at this, the first one was what I did first. You notice I started I to be size, which is not a valid spot, but I did so because I was thinking, okay, I'm checking to see if the spot before this has a, well here, hold on a second. It has, whether it has a name that's bigger than this name. And so if this name is smaller, it needs to go further down on the list. I'm starting from the end. One thing I do want to stress is that you, well, first of all, this is an array list. And so, well, more to the point, get name gets you a string. And then if you want to compare strings, of course, you have to use compare to. And a lot of times we're in the habit of using like greater than or less than to try to compare things. And that's just not safe. You have to be dealing with primitives. I mean, if you had integer objects, it could be okay there too. It's just a better rule to use compare to as your default to compare things rather than the less than or greater than symbol. And just expect that. And so anyway, we're trying to see if the one before this has a name bigger than this one, and if so, keep moving to the left. And then when I find out where it belongs, I add it and done. This one's cleaner. The second version is cleaner because I just started at the beginning, and then if the one after this is smaller, then I need to keep moving to the right. And the same idea is working from the beginning of the list. And either way, it's fine. Question so far? Then now back to the, hold on. Now to the like the distinct number of peaks, that method, distinct peak names. Now, what they gave you would work only on a sorted list because it checks to see if the one next to it is the same or not. And if they're different, then it counts it. Otherwise, it doesn't. But that won't work here. The idea I went with was I said, okay, the first one, if you have, you know, the first element, I'll just skip that. Okay, you know, it's different from anything I checked before because I haven't checked anything yet. Then we get to the second element. So I had a loop that starts at spot 1, and I compare that one to all the ones that precede it, and basically I'm checking to see if any of them match. So if none of the ones that precede it match, then I count it. And so, of course, the only thing before whiteface is Monodoc. I haven't tried to pronounce it yet. And so whiteface gets counted. Good. And then my outer loop moves on to spot 2, and I loop through everything that precedes that. And none of them match Algonquin. And so Algonquin gets counted. Then my outer loop moves on to the next spot, and my inner loop checks everything before it. And because I got a duplicate there, then this time it wouldn't get counted. And voila, it works. So you have to, and I'm not showing you that code. You have to imagine you have a loop inside of a loop. And I have a counter variable counting the number of distinct peaks, which I set that to be 1 initially. So that's counting the first one. And of course, if you had size 0, that's a special case. You can even consider a size 1 a special case where you don't even have to worry about the loops. But you don't really need, I have to look at my code again. You may not need those special cases. You know, probably the loops won't even run if the size is 0. So anyway, like I said, let me go through it again. You make a counter variable, set it to 1. Then you make your outer loop start at the second element, spot 1, and then the inner loop compares loops through everything preceding that. And if you find a match, it doesn't count it. If you don't find a match, then it does count it. And then your outer loop moves on, and you loop through all the preceding ones, and you repeat, repeat,